Got it. Okay, good afternoon. Wow, it's been a year already. We're back. Okay, so or I'm back. Yeah, all right. So again, my name is Brian Kowalczyk and Gabriella Ziegler. We're here to give college technology updates. So first off, we have a computer information systems change. Our co-op program is currently on hiatus starting this semester, and we're regrouping with internal and external stakeholders on that, trying to work out some of the kinks that we have that were slowing it down. It's overall something that both sides agree that yes, this is a good thing to do, the co-op, where they can get students and grow them. It's just we have to work on the business needs on their side, and the academic needs on our side have to be able to align, and we have to work out the mechanics on that. So we are planning to meet with a group of them in the coming months to start working towards that goal to see if we can't reconcile, and hopefully we will be able to revive that, because there's a huge need for IT talent out there that we're trying to fill the pipeline with on this program, which would definitely help. So okay, so moving on to computer science. So there are no other real CIS changes. Okay, computer science, we have moved a number of courses. Okay, well, again, and this is a summary. We're going to go talk about each point on subsequent slides. So this is kind of an overview. We moved 3 courses into the Foundations of Excellence in the computer science program. Right, we moved 1 course into the Foundation of Computer Science, moved 3 courses into the major, added 1 course to the major, removed 3 courses from the program that had to do with the 3 courses coming in. Okay, and we rebranded the computer architecture and algorithm specialty. Now, when we say that we moved courses, that means we moved existing computer science courses into those slots. We didn't invent new courses. So there's, of this movement here, there's really only 1 new course. 2. Yep, add 2 courses. Okay, how's that? Better? I can hear that better too. All right. I don't like hearing my own voice, but okay. Okay, so we have some movement. Basically, we moved some courses around, and we'll talk about each one in turn and the rationale why we did that. So, oh yeah, I'm sorry. And the electives keeps me honest here. Okay, and these actions have reduced the open electives to 9 credits. Okay, which we'll talk about at the end. I know that's a smaller number than we'd like to see, but we still have some flexibility for them to choose some elective courses. Okay, so math, everybody loves math, so we gave them more. Okay, all right. So, all right, we have added or moved 3 existing courses: Math 350, differential equations, physics, okay, applied physics and applied physics lab, and we added 1 credit hour to the linear algebra program to increase it from a 3 credit hour class for a 4 credit hour class. Okay, these will help us, increase the mathematical rigor, exposure to the physical sciences. Okay, and it bolsters preparation for employment and graduate work. Okay, a lot of our students in the CS program are going on to graduate studies, and this helps prepare them for that. Okay, data communications and networking. We added data communications and networking. It was an existing networking course. We added it to the program, okay, because students need to strengthen the foundation. We need computer networking is part of programming, and as such, we need to make sure that the programming students have a foundation in networking, understanding how they're actually communicating, which will help them build better programs. And when things don't work properly, will help them diagnose what's going on and why, rather than, you may have been there, I've done that. Well, that's a hardware problem, or that's a software problem. We don't have to throw it over the fence. We can dig in a little bit and say, no, that's a hardware problem, and here's why. Okay. All right, 3 existing classes we moved into the major on computer science. Assembly language and computer architecture moved from the specialty into the major. All right, so all students will take it. Okay. Distributed and parallel systems is an existing course in computer science. We moved it to the major and renamed it at the same time, which makes the paperwork really confusing. But what it does is we added the word parallel there to the distributed and parallel systems to address the need that what we already were covering. We're just showing that we are covering this again. Graduate studies want to see that students have experience in parallel computing, where we're doing things simultaneously rather than sequentially, and we address that in that course. And we just wanted to make it very clear that's what we're doing. And CSCI 430 operating systems, one of my favorite courses. All right, we moved that into the major so that all students will get exposed to operating system concepts rather than just a select specialty. Overall, these courses were identified as essential elements in a computer science program. We wanted to make sure that all the students were getting that solid foundation rather than just a select specialty. Okay, we added a new course, okay, concept of programming languages. Okay, we did this because it adds, we're very strong in programming. That's one of our differentiators, that we offer a lot of different languages: C Sharp, C++, Java programming, Visual Basic, Perl, Python scripting. We're very, we got a lot of the hot topics today, and hopefully coming into as tomorrow. And what the concept of programming languages, it covers the theoretical approach for what is a programming language and why do they do what they do. Okay, and that lines us up for a couple other things in the future. But this gives the technical-minded programmer um, additional information. Why does Java do it this way, and why does C Sharp do it that way? Okay, and that helps us answer questions. What's the right tool for the job? What's the differences between the languages? So this is really the starting of how do you design a computer programming language rather than just learn how to use one. It's like so in case, English, I'm still trying to learn how to use English like I would computer programming, but I don't take a syntax or semantics class to learn how I could actually create my own language, right? Verbal language. So that's the kind of difference. So that's what we're talking about in the concept of programming languages, is what makes the computer programming language do what it does and why, and what are our options. It does this way, but what are the other options? So that aids in analysis there. And again, rationale, the theoretical design of computer science is important, and advanced programming makes use of this, as well as graduate work. Okay, so our graduate students in our master's program would also benefit from this, as well as out in the field, advanced programmers would know why certain things would or would not work when they're designing a system. Okay, now we moved a couple of courses out of the specialty. Okay, specifically, we moved operating systems out of the specialty, which took it from 12 credits, okay, down to 9. And we had to decide, do we want to keep the specialty? And the answer was yes. So we're like, okay, what would bolster that? And all right, now this is a British word. All right, I blame Alan Turing for this one. All right, automa theory. All right, and compiler design. So we added this course to the specialty since operating systems was removed, and this course complements the programming language course we just talked about. Is the first one is the design and attributes of programming languages. What are they? How do they behave? Why do they behave that way? And this one is, how do you make one? Okay, how do you actually design it mathematically, and how do you prove that it is accurate and complete? And then the compiler design is, how do you actually produce make a computer program that can execute on the machine. So how can we take that word processor type source code that we type in, where we make heavy use of semicolons and all kinds of things that make English people cringe when they're looking at our what we call grammar, and then how do we turn that into an actual program that the computer can actually execute? And that's the compiler design. So this gives us, it complements the new course, concept of programming language, and it provides a pathway for technical-minded programmers to get to a specialty, to say, hey, I like programming, I'm in here very strong. Again, Davenport is known for its programming language selection, and that we produce a really good quality programmers, and we're just strengthening that by providing the theoretical foundations plus an ability to apply that theory into potentially making your own programming language. Okay. Now we removed, since we bolstered some of our upfront, differential equations, Math 350, we were able to, at this point in time, take and say, hey, finite math and statistics, we can come back and say, well, we have this other math, finite math and intro to stats, we're going to have to remove. Okay, not that they're bad courses, but we're looking to go with the calculus route, being more aligned with engineering type curriculum, where we're taking Calc 1, differential equations, linear algebra, all right, and not that, and also principal project management. Okay, good class, great. We're actually going to encourage our students to take that, but we felt that giving them an option to do that and suggesting that they do that, we really don't want to cut down from the 9 credits to 6. So we want to go back and say, well, you have choice. We'd recommend you take project management because you have to work in teams and there's value there, but we didn't want to dictate that to them, right, at that level. And all throughout this, we talk about, well, what makes a computer science program? What makes a computer information system program? And a lot of our guidance comes from the Association from Computing Machinery and IEEE, which are flagship journals in the computer science area. So what we are doing is bouncing our curriculum off the published guidelines for here are recommendations for curricula, and we just look for math credits and things like that and see how we're balanced. And what we find is we have a very good balance in computer science, okay, and that these changes are in line with those recommendations. Now, we weren't trying to match them and say we got to duplicate these because you can't. It's just simply recommendations. But what we looked at is to make sure that the direction we were heading in at least was grounded in some type of research that they've done, and it fits. So what we're saying is our computer science isn't way out in left field or right field, totally different than anyone else. It's pretty much what we have in our program is within the boundaries of what they would consider to be reasonable topics for computer science graduates. We did move computer assembly language and computer architecture out of the specialty, which was named computer architecture and algorithms. So our algorithms course moved out of the specialty into the major. So then we're like, well, our major now doesn't, or the specialty does not have depth in algorithm or architecture. So we're like, well, we have to address the name. So we came back and said, okay, well, it's really computer theory in algorithms based on the content. So we made a slight name change. We took the architecture out and replaced it with theory, okay, which should excite most everybody, okay. All right, but it does recommend and it does outline what we've done and why. All right, and a couple name changes, okay. Secure software changes to secure software analysis and design. Okay, secure software is great, but it didn't say much. And now we just added the analysis and design to say, hey, we're going to analyze this, understand why, where, and how it needs to be secure, and we're going to design the software that way. So we're just using all of our words to describe the course. And then GMPT, some of you may have known that the project, the PMI Institute, went from PMBOK version 5 to PMBOK version 6. So the PMI Institute, upped their game, went to the new version of their body of knowledge, the PMBOK, and our changes reflect what they prescribe to us for the PMI. So slight name change to accommodate the version 6 of the PMBOK. And special topics, think as a CIO. Okay, and studies have shown that, well, using the word special and CIO probably shouldn't happen in the same sentence. So we just changed it pretty much from a special topics class just to, hey, it's the classes think it's a CIO. All right, it's not a special topic class. That's what the class is going to be. It's not going to change yearly or based on what the connotation of a special topics would be. And as we already discussed, the distributed systems class was renamed to parallel and distributed systems to call out the fact that we actually do, okay, talk about and study parallel systems as well as distributed systems. Right now, getting all the way back to the very first slide where we said that there were 9 credits now. Okay, and some of you may say that's not very many. We used to have a lot more. And I agree with that. We used to have quite a few credits into the computer science program. We are working with, and I've attended one meeting in Jackson, and we're going to go back in, what does it say, May? I better not forget that, put that on my calendar. But we're talking specifically about how do we transfer in the state of Michigan. A lot of the community colleges, Davenport was represented. We had Grand Valley there. We had a few of the state colleges there, a lot of the community colleges there. It was really a good opportunity, and there were some good discussions on the bigger picture of, how do we transfer in? All right, it was specifically focused on computer science, and we were laying out essentially what an ideal transfer program would look like across the state. So I'm very hopeful that this will help. So I know a lot of you have, sometimes some challenges from community colleges trying to transfer them, and we want to minimize the loss there, and we are looking at that. So we are participating in this initiative towards that goal. And even though we have taken some of our open electives down, it was for good reason. But we also are keeping an eye on the transfer issue and trying to do what we can, both here at Davenport and across the state, by participating and making our voice heard and understanding both sides. And surprisingly, in computer science, it's been pretty well received, and I think we're going to see some good things come forth out of this initiative. So. And I'm not supposed to say this, but anybody have any questions?
In the Masters of Computer Science, in the Master Project and the Master Research, they're both 6 credits. How do we identify these classes when we're scheduling them? Because it's not a full semester for 6 credits.
The way we're doing it is we're gonna schedule the first 7 weeks, and the second one is the second 7 weeks. Maybe there is a different way that we can change the name later in the UCC, but at this point, the first class is the first 7 weeks. It's one project. It's just there is not enough time to cover it in 7 weeks, and with 3 credits, and we don't have a 6 credits offering. So the first class will be the first one. They pass that, and then they can go into the second class that will be the second. Same project, is just moving on the complexity. But they cannot go in session 2 if they haven't taken session 1.
So we're just, for those of you on the live stream, we're just talking about cancellation. So if one is canceled, then what happens to the second one, I believe. Is that correct?
Will need to be canceled too. We have to take a look at it, and we will. I mean, to see how it's offered, because it has to be offered in the same semester, first 7 weeks, second 7 weeks. Students that take in the first 7 weeks, to graduate, they have to take the second one, the second 7 weeks. One student for, you know what I mean? So we have to offer it in the same semester. So there is something that we miss. We'll take a look at it. Thank you.
Thank you.
I have a question from Lansing. They would like an update on the ABET accreditation.
So we are still working on that, and probably all of you know that the accreditation is a long process that implies a lot of processes and changes and compliance that you have to have, and we are doing all of that. So we are in the process of working towards making our curriculum and processes better.
Yeah, you got that. So, but anyhow, thank you for that. We'll provide updates on a more regular basis as we move through, so we can stay up to date, because we're all very excited about that.
Just a quick clarifying question. With the open electives, is it 8 or 9 credits? Because in here it says 8 in the summary of changes, and then on the PowerPoint it said 9.
I believe the summary of changes.
So we can double check that. I believe
Okay.
it's 8, but we will thank you for that.
Oh, yeah, you know what that was? Yep, I got that. That was the linear algebra credit.
You forgot the 1 credit.
Run credit for the linear algebra. That's on me.
Blame him. It's 8 credits then, so it's settled. Okay.
Great.
Thank
you so much, Brian and Gabriella. Thank you for the good questions. Thank you.